All right, here we go. Number 2. You pick up a 3.6 kilogram can of paint from the ground and lift it to a height of 1.4 meters. So I'm going to assume that on the ground it wasn't moving, and when it gets up to the height, it isn't moving either. How much work do you do on the can of paint? You hold it stationary for half a minute, waiting for a friend or a ladder to take it. How much work do you do during this time? If your friend decides not to use the paint, you lower it to the ground. How much work do you do from the can as you lower it? All right, so we've got 2 graphs to do on this one, right? 2 moves to 2. And you didn't even do your homework. All right. So we've got from when the paint can was on the ground till it's up in the air, and then from it up in the air down to when it's on the ground. So let's see. We got kinetic energy, maybe. What type of potential energy is involved here? Gravitational. I would go with gravitational, yes. So I'm going to label this second column as PE grav. Subscript. Oops. Alright. So, when the paint can's on the ground, is it moving? No, so no kinetic energy, right? How much potential energy do you grab when it's sitting on the ground? 0. And then when it's up in the air, not moving again, right? Just standing there, up there. Oh, but it's going to have some PE grav, right?
Yep.
Give it a little PE grav. Yeah. So, is my energy conserved in this right now? Nope. I must have done some work to get it up there, right? So now, initial plus during equals final. Yay! Alright, now that whatever the final was there at the top is going to be the same as my initial here. What did I do? 1, 2, 3, 4, 5, 6, 7. So might as well grab the same color just to reinforce that. 7. And then I lower it, and it's back on the ground. Oh, so the back on the ground is 0 again. That means I had to do work to lower it, right? I gotta take away energy. 1, 2, 3, 7. Yeah. So on the way up, I add energy to the paint can. On the way down, I take energy away from the paint can. Yay! How many people had that? 1, 2, 3. So,
Wait, I don't get it. Why is it 2?
Oops. It would have been good if I was recording. PE grav. So I'm going to use my sheets, my graphs, to start my problem. So let's see, I am asked, how much work do you do to lift the can of paint? So this is part A. And so part A, on my graph, the work I did equaled the PE grav at the top. So T for me stands for top. That, okay? So, the work I do, mg, h, height at the top. You know, that work equals the P is directly from up above. Mass of my paint can, 3.6 kilograms, 1.4 meters. What planet am I assuming this is happening at? Earth. That's a good, I think that's a good assumption. 3.6 kilograms on Earth, so 9.81 newtons per kilogram. Height of 1.4. 1.4 meters. Okay. So I have meters and kilograms and newtons and all those fun things, so I know I'm going to end up with joules. So I ended up with 49.4 joules, which I'm pretty confident. Good? Then part B, how much you hold the can stationary for half a minute waiting for a friend on a ladder to take it. How much work do you do during this? Oh, this is just like that experiment we did holding the books out.
Yeah.
Oh, so you guys know the answer to B. Zero, zero, and then part C. Oh, wait a minute. If I look up on part C, looking back here, if I look at my graph, part C, I did opposite the work of the PE graph, and I already figured out the value of the PE graph, right? Oh, so part C here should be just the work equals the opposite of the PE graph. So negative 49.4 joules. Yeah. But if I didn't do my graphs, I might not know that that had to be a negative. All right, number 4. 70 kilogram bicyclist rides his 7.8 kilogram bike with a speed of 16 meters per second. How much work is done by the brakes to bring the bike and the rider to a stop? And then what is the magnitude of the force on those brakes? And notice they want the work in kilojoules, right? Now you could do it just in joules if you go in here and delete the K. And it's smart enough it'll understand that. Right? So it's up to you guys. Okay. So I'm going to do my graph. And what color do I like this time? Let's go with, we'll go with purple. So the bike and the rider together start off, they have a lot of kinetic energy. And then afterwards, they're stopped. So no kinetic energy afterwards. I'm going to assume they're on a level road, so I don't have to worry about gravitation. Right. And because it gives me no information about if they weren't on a level road, so yay, there it is. Yeah, I mean, if you wanted to put a line down here or write 0 in there, just make yourself realize, hey, I did that, I would never take off for that. Yeah. Let's see, I need my kinetic energy equation from Unit 1. Alrighty. And from my graph, I said that the kinetic energy must equal, the kinetic energy to start must equal the work done by the brakes. Now I know that that work, is that positive or negative work? Negative. But I'm just going to put it in there and figure out the magnitudes. All right? No, that's, you have to 6 lines.
Well, it had glasses. Yeah, me too, that's what I thought was asking.
No, this is 6 lines. The only use I had to make it to the side.
Is it okay?
It was before I did. Alrighty. I could if you wanted to, but it doesn't matter. We're just looking at the magnitude, how big it is, and we know that they're the same size. Yeah.
What's the subscript?
I and then brakes. Initial and then brakes. Yeah. My guess is that they want the positive. Yeah, because they're saying how much work. And work, yeah. Yeah, the last one we did the negative to emphasize that we were doing work on the paint to add energy, and then we were taking energy away by lowering it. Yeah. So my gut is. But if I get it wrong the first time by putting in a positive, I'm going to throw a negative in there and see if I get it. Yeah. Because from this book, sometimes it's hard to tell. Oops. Alright, so I need to keep in mind, though, that I'm talking about the rider and the bike together, right?
Yes.
So I'm going to substitute in using my equation. So I'm putting in 1/2. This is going to be the mass of the biker, the bike, and the rider.
There you go.
And then their speed squared equals the work done by the brakes. And now I substitute in, what do we got, 70 and 7.8? And I'm looking at this, and I've got kilograms and meters per second. Folks, remember, if you don't need this one, that's fine. If you want to work with someone else, go over them and the other table so that I can hear myself think, okay? Thank you. I've got kilograms and meters per second and everything, so I know I'm going to come out with joules. So I come out with 9,958.4 joules. And I'm going to keep in mind that this is negative. You just did it. I'm going to put in a negative because I'm taking energy away. Convert that to kilojoules. I'm going to actually end up with 10.0 kilojoules. Because I'll move it 3 places and then rounding. Actually, sorry. Given my rounding, I'm not going to end up with 10. I'm going to end up with 9.96 kilojoules. But I am going to put in negative because energy is being taken away. So negative 9.96. Yay!
Your Crawford, have you ever gotten a problem wrong when you were doing this?
Oh yeah.
That's so awkward.
Usually,
That's so awkward.
alright, now we need to do part B, which says what's the magnitude of the braking force when it comes to rest. So we need an equation again. This time we need the one for work, which is right down here. Drop that in. And so we're told, I think we're told how far it travels. It comes to rest in 6 meters. So substituting in here, make this a little bit bigger. Ooh. So I've got 9,958.4 joules equals force due to the brakes, which I don't know, times 6.0 meters. So I get 1659.733 newtons. I noticed it wanted 2 sig figs. Oops. And knowing our book and that they don't use the correct rounding techniques, I'm going to put it in as 1,700 newtons.
Does it have to be negative?
No.
Okay. Oh yeah, because there's no, yep.
It's in newtons. My guess is it's going to take 1,700. Yep. Although actually, oh, it says 2 sig figs and it actually wanted 3. Oh, sneaky little book. I might have to update that text.